Hey everybody, Sebastian here again. Today I'm going to talk you through the creation of a custom tool within the HAL Robotics Framework. So without further ado, you'll see here that I've built myself a pencil holder, which will fix itself onto the robot, and I've also marked up here a point that is the tool center point, or TCP. So first things first, I'm going to bring all of these meshes into Grasshopper. There we go. And again, good habits, hide everything as we go, just to keep things clean and avoid duplication of visualizations. And I'm also going to bring in that point, which we're going to need imminently anyway. And there we go. So I'm going to hide that as well. Now within the HAL Robotics Framework, you'll see in the Cell tab that we have Controller Part, Robot and Tool. These top ones here are all for grabbing things out of the catalogs, be they local or the remote ones that we provide. The group of components underneath are all for creating things from scratch. So if we create tool, which is what we want to do ultimately, we'll see here that the components that make up a tool are actually parts. So we need to feed it a whole load of parts. It's not just a mesh that goes in. It's a little bit more complex than that. So if we come back under Cell, we'll find Create Part. Part, however, is that simple. So it's asking for a body, which is all of our meshes here, and it's asking for a frame, which is, in this case, going to be the frame that connects this part to the robot. So it's really important that these line up properly. What I mean by that is you'll see here that I've created my part on the origin with the x-axis coming this way, y, and therefore z coming up. It's really important that, especially if this is a directional tool, that lines up with what the robot expects. So if I grab myself a robot out of the catalogue here, grab myself an RB 1200 again, and put that into my scene, you'll see that on the end of the robot, where we're going to connect the tool, there is a frame. And in this case, Z is coming out, X is coming down, and Y is coming out to the side. It's really important that we make sure our base frame for our part matches with our expectation of that and how it's going to connect to the tool. So I'm just going to hide our robot quickly here, put them over to the side, and well, actually you'll see, because we are on the origin, the world frame will do in this scenario. So I'm going to grab myself an XY plane and use that as the frame. And now we have a complete part. So as we saw before, a tool wants a part or several parts, and it asks for an alias. It's always good to name things so that we know what we're dealing with later. Oops, pencil. And it's asking for a TCP. So the TCP, or the tool center point, is the point of the tool that's actually going to reach the targets that we assign it to. So in our case, that's the tip of the pencil here, which I've already got as a point in here, and it needs to be a plane or a frame. So once again, the alignment is really important. I've tried to keep things simple, and actually an XY plane based at this point will do just fine for us in this case as well. So we're going to grab an XY plane there, pass that into the TCP, and you'll see that it pops up as a frame, aligned with the world and aligned with the frame at the bottom, and it's now labelled my pencil holder TCP. Now that we have a robot and a tool, it's time to bring back everything we did in the Getting Started tutorial, which was assemble a robot with its tool. So if I bring that in here, I'm going to hide everything we don't need, turn this on, and if I pull away, you'll see that as soon as I connect this tool to the robot, it jumps into place on the end of the robot there, and we can see exactly whether it's aligned or not, and change that if need be. So I'm going to keep hiding things that we don't need, come all the way along, and I'm going to plug a simple curve into our controller, exactly as we did in the Getting Started tutorial. And when I hit execute, you'll see that our new tool is actually following everything we're doing. And there we have it. A very simple custom tool in the HAL Robotics Framework. In a later tutorial, I'll talk about how we can get the exact calibrated data from your robot controller back into the simulation. But for the time being, that should be enough to get you started. So, I'll see you next time. Bye.